Hello everyone, my name is Justice Speechak. I'm a cybersecurity analyst and blue team content creator. Today we're going to be covering the Linux login for SOC TryHackMe room. If you're already in the SOC level 1 learning path, you will have access to this room. So that being said, let's get started with task 1, introduction. So starting off, Linux has long been a leader in servers and embedded systems, and now it's used in even more widespread with the growth of cloud adoption. As a SOC analyst, you're now very likely to investigate Linux alerts and incidents either from traditional on-premises servers or from cloud-native containerized workloads. In this room, you will explore the most common Linux logs sent to SIEM, or however you pronounce it, and learn how to view them directly on host. Learning objectives are: explore authentication, runtime, and system logs on Linux, learn the commands and pitfalls when working with logs, uncover how tools like auditd monitor and report the events, and practice every learned log source in the attached VM. Also, here's some recommended rooms for more further clarification. And to access these rooms, you can just click on them. So open link in new tab. And it will take you to the rooms: Linux Fundamentals 1, Linux Fundamentals Part 2, and Linux Fundamentals Part 3, Linux Shells, and Log Fundamentals as well. So if you wanted to do those rooms, you have the links to do that. And by all you need to do is click on these rooms and you'll have access to them. Alright, if they are free. Next, before moving forward, we're going to start the lab by clicking the Start Lab Machine button below. The machine will start in split view and it will take about 2 minutes to load. So in case the machine is not visible, you can click the Show Split View button at the top of the task. And you may need to work as a root user for some tasks. So to switch to the root on the VM, please run sudo su. So let's start the lab machine. And now let's boot it up. And also, if you wanted to, alternatively, you can access the VM from your own VPN connected machine with the credentials below. So give it some time and the credentials will show for IP address via SSH. And to see the different connection methods, you just need to click here and you will see instructions. Access via OpenVPN Advanced. You can either use the attack box, Squawker VPN, or OpenVPN Advanced, and all the instructions and what you need are here as well. Alright, for this room, we're going to be using a really helpful resource that I wanted to provide and talk about, and that is the Linux forensic reference associated with DFIR reference. So you have probably seen me use this resource for the Windows rooms, such as, for example, Windows forensic reference tools. I've used the Windows security event ID reference and system event ID reference for when I was going to, for example, through the Windows Threat Detection 1 and Windows Login for SOC TryHackMe rooms. In this case, I'm going to be using the Linux forensic reference to help you guys better understand the concepts. For instance, for the Linux forensic artifact reference, there is Unix forensic artifacts such as log files, configuration, persistent locations, and file system indicators, map to minor attack techniques, and real Sigma HQ detection rules, auditd, built-in syslog, process creation, file event, network connection. And it also is the companion to the Windows Registry Explorer. So if you wanted to get a better understanding of the logs associated with Linux and much more, this is a really great resource to bookmark, and we're going to be using this to help you better understand the concepts in the Linux Login vs. SOC TryHackMe room. Nice. The Linux room is already booted up. And if you wanted to use your VPN connected machine, here's the IP address provided. And to complete the task, all you need to do is click on correct, and you have completed this task. And to be completely transparent, I have already completed this room, but don't worry, I'm gonna help you guys walk through the tasks so that way you understand how I got the answer and overall the problem solving methodology. Alright, next. Task 2, working with text logs. Log format. Contrary to a common belief, Linux-based systems are not immune to malware. Moreover, Linux-targeted intrusions are a growing problem. Thus, as a SOC analyst, you will often need to investigate Linux alerts, and for this, you will need to understand how its logging works. Now, let's clarify a couple of things and move on. By Linux, the room refers to Linux distributions like Debian, Ubuntu, CentOS, or Rail, or Red Hat. Also, the room focuses on Linux servers without a GUI, which you can see here, and does not explain desktop logging. So working with logs. Unlike in Windows, Linux logs most events into plain text files. This means you can read the logs via any text editor without the need for specialized tools like Event Viewer. On the other hand, default Linux logs are less structured as there are no event codes and strict log formatting rules. And most Linux logs are located in the var log folder. So let's start the journey by checking the var log syslog file, which is an aggregated stream of various system events. And so if we go to our resource, we say offlog secure, and much more. So yes, and since it mentioned syslog, an aggregated stream of various system events, if we click on system kernel and audit logs, we will see syslog messages here. So what this is, it is a general purpose system message log aggregating kernel, daemon, and application log lines via rslog syslog-ng. It also has the path location, the forensic value, which is that it is a broad spectrum timeline source. Also, the log attackers most commonly try to clear or truncate, so its integrity or lack thereof is itself informative. And also you have the tools and parsers and stigma detections as well. Alright. Cat, varlog, syslog, head, and which shows us the logs. So I'm going to show you guys another really helpful resource, and that is Explain Shell. It's one of my favorite. So I'm going to go to Explain Shell. I'm going to type in, we're going to paste this. Explain. Alright, so what this does is that you can type any command and it's going to break it down part by part. So for example, cat is concatenate files, which is a pipeline is a sequence of one or more commands separated by one of the control operators. So overall what cat does is that if you wanted to output something, cat is the command to do it. So we're outputting everything in the varlog syslog folder. And then we're going to output the first 10. Yes, the first number of lines of each input value. So basically what head does is that we're going to output the first 10 logs of varlog syslog. And also if you wanted to learn more about head versus tail. So if you go back. So head and now we got tail. So what tail does is that it prints the last 10 lines of each file to standard output. Head, on the other hand, is going to copy the first part of files. So if you wanted to output the first 10 lines, head will do that. Tail is going to output the last 10 lines of each file. So what this does is that we're going to output varlog syslog, and we're going to take the first 10 lines of our output, which is here. Alright, so filtering logs. You will see thousands of events when reading the syslog file on the attached VM, but only a few are useful for the SOC. By the way, SOC is not clothing. It stands for Security Operations Center for clarification. So if I show you cat var log syslog, and then we pipe head, it shows us the first 10 lines. Also, let me view in full screen so that it's easier to see. Cat var log syslog head. Nice. And also, I can do man head. And it shows us output the first part of files and description. It prints the first 10 lines of each file to standard output. Nice. Alright. Moving on. That's why you must filter logs and narrow down your search as much as possible. For example, you can use the grep command to filter for the cron keyword and see only the cron job logs. So let me minimize. So what we're going to do is we're going to do cat var log syslog and then grep. Going to grep cron. And what that does is that, or you can use grep-v cron to exclude cron from results. So basically, if we wanted to use the grep command to filter for the cron keyword and see only the cron job logs, you'll see it here. But if we wanted to filter out cron, we can do grep-v and then cron. Actually, my bad. Exit. Oh, it's doing the thing again. Alright, let me just see. Let me do one thing. Let me cat var log syslog grep-v cron. And now we have outputted everything that doesn't include cron. Awesome. Alright, discovering logs. Lastly, let's say you hunt for all user logins but don't know where to look for them. Linux system logs are stored in the var log folder in plain text. So you can simply grep for related keywords like login, off, or session in all log files there. And narrow down your next searches. So for example, to show you guys, we're going to do ls-l var log. And it's going to show us syslog here. And to learn more about a command, you can do man ls. And it's going to show you the name, synopsis, and description. So for ls, it lists information about the files. And for grep, what grep does is that it grep searches for patterns in each file, and patterns is one or more patterns separated by new line characters, and grep prints each line that matches a pattern. And typically, patterns should be quoted when grep is used in a shell command. You need different options as well, pattern syntax, and much more. Awesome. All right, give it here. Login caveats. Unlike Windows, Linux allows you to easily change log format, verbosity, and storage location. With hundreds of Linux distributions, each known to slightly customize logging, be prepared that the logs in this room may look different on your system or might not exist at all. So we got some questions to answer, so let's do this. All right, we're going to use the var log syslog file on the VM to answer the questions. So which time server domain did the VM contact to sync its time? So, and also we have a hint. You might need to use the grep command and look for time sync events. So we're going to use cat var log syslog and look for time sync events. So we're going to time sync. And we see ntp.ubuntu.com here. So let's look up what that is. So Google, what is ntp.ubuntu.com? .com. ntp.ubuntu.com is the default network time protocol's NTP server address used by the Ubuntu operating system to keep its system clock synchronized and accurate. So this has to deal with time. And that's going to be our answer, ntp.ubuntu.com. Next, what is the kernel message from Yama in var log syslog? And we also have a hint. Our hint is that once again, you might need to use the grep command here. So we're going to go back. And we're going to do cat. Also, you can just do this. You can also use the arrows to go back to your previous ran commands, which is very helpful. But also, you can do, I believe it is cat bash. So you can do history and see the commands that you have ran previously. So that way, if you wanted to use a previous command, you can use the history command to help you better understand what you executed. So that being said, we're going to use cat varlog syslog, and we're going to look for Yama. And we see here. And so what it wants us to find is a kernel message from Yama in varlog syslog. And we might need to use the grep command here. So let's do that. Let's look for Yama. And we got a message, becoming mindful. Awesome. All right. Moving on to task 3. Authentication logs. So, the first and often the most useful log file you want to monitor is varlog auth.log or varlog secure on rail-based systems. Although its name suggests it contains authentication events, it can also store user management events, launch sudo commands, and much more. Let's start with the log file format, which can be found below. So authentication events example, varlog auth.log. You have event time, host name, process ID, which can be found here, and message from the process, and it can be of any format. So we have those as well. All right. Login and log out events. There are many ways users authenticate into a Linux machine, locally via SSH, using sudo or su commands, or automatically to run a cron job. Each successful login and log off is logged, and you can see them by filtering the events containing the session opened or session closed keywords. So if you wanted to see that information in auth.log, we can do cat var log auth.log and then grep -e for session, I believe it is session opened and session closed. And we can see all the events that are either session opened or session closed here. Also, I want to point out for Linux forensic reference, we can also look at authentication and session logs. So for example, we have auth.log secure, which is a primary authentication log recording SSH logins, sudo invocations, su usage, PAM session opens, closes, and failed password attempts. And the path location can be found here. Varlog auth.log for Debian and Ubuntu, or varlog secure for Rails CentOS. And the forensic value of this is that it is a first place to check for brute force attempts, successful unauthorized logins, lateral movement via SSH, and privilege escalation via sudo and su. And timestamps here anchor an intrusion timeline as well. And your tools and parsers, and your Sigma detections here. Awesome. All right. We have that. All right. In addition to system logs, the SSH daemon stores its own log of successful and failed SSH logins. These logs are sent to the same auth.log file, but have a slightly different format. Let's see the example of 2 failed and 1 successful SSH logins. So for example, if you wanted to use auth.log and grep for SHD, so we're going to do that. We're going to grep SHD, and then we're going to grep-e for accepted or failed. And we can see the accepted or failed logs here. Awesome. All right, miscellaneous events. You can also use the same log file to detect user management events. This is easy if you know basic Linux commands. If user add is a command to add new users, just look for user add keyword to see user creation events. Below is an example of what you can see in the logs: a password change, a user deletion, and then privileged user creation as well. So in this instance, we see a password change, we see a user deletion, and then a privileged user creation, which can be found here, and then the user being added to a group. Lastly, depending on system configuration and installed packages, you may encounter interesting or unexpected events. For example, you may find commands launched with sudo, which can help track malicious actions. So in the example below here, the Ubuntu user used sudo to stop EDR, read firewall state, and finally access root via sudo su. All right, we have some questions to answer now. So we're going to continue with the VM and use the var log auth.log file, and which IP address failed to log in multiple users via SH. So we're going to use our command that we ran, which was cat varlog auth.log grep shd grep-e accepted failed, and we're going to try to find the IP address which failed to log on multiple users via sh. So we have to go to failed, and we see that the IP is going to be 10.14.94.82 because we see failed results for multiple users such as root, admin, and support, and we see the IP address mentioned. So it's going to be 10.14.94.82. Nice. All right. Which user was created and added to the sudo group? So we're going to use this command right here. So we're going to do cat varlog auth.log grep-e, and in our parentheses we're going to put password. I want to make sure I get this right. Password user add, password user add, user mode, and the other one is user del, and then this, then okay, I think that's everything. Yes, it is. Awesome. So if you run that, we have our results that mention password, user add, user mode, and user deletion. So that way we can see anything associated with password changes, user additions, user modifications, and user deletions. So we're going to try to find the user which was created and added to the sudo group. So we can see that there was a user called xcr-xes added to group sudo. So that's going to be our answer, which is correct. Nice. All right, moving on to task 4, common Linux logs. So, generic system logs. Linux keeps track of many other events scattered across files in var log. For example, we have kernel logs, network changes, service or cron runs, packet installation, and many more. Their content and format can differ depending on the OS, and the most common log files are varlog kern.log, which has kernel messages and errors, which is useful for more advanced investigations, varlog syslog or varlog messages, which is a consolidated stream of various Linux events, varlog dpkg.log, which is packet manager logs on Debian-based systems, or varlog dnf.log, or varlog yum.log, which is the packet manager logs on Rail-based systems. And these listed logs are valuable during DFIR, but are rarely seen in a daily SOC routine, as they are often noisy and hard to parse. Still, if you want to dive deeper into how these logs work, check out the Linux Logs Investigation DFIR room, which can be found here. So if you wanted to learn more information about the different logs associated with Linux systems, this room is a really great resource for you. And also, the Linux Forensic reference is also a really great resource. So if you wanted to talk about system kernel and audit logs, we have the information, packet management, dpkg log, network configuration, kernel modules, and rootkit indicators, Gen user command history, and much more. So overall, the Linux, lots of Linux today, the Linux Logs Investigation room, I highly recommend to check it out because it's going to help you better understand Linux system logs for effective incident response. And also, if you wanted to bookmark a really helpful resource or use it, the Linux Forensic Artifact reference and this website is overall a really great resource to have as well, which I am going to bookmark. So I'm going to bookmark the HTTP Windows reference room, so that way I have it right here for reference. So that way I have this information on standby. Awesome! And also we have Linux forensics tools to help you guys out as well. Super helpful. Alright, for example, we have auditd, Linux Audit Framework User Space Tools, and the user space tools auditctl, all search, all report for the Linux kernel's audit subsystem. It configures audit rules and queues reports on the resulting audit.log. And we also have a use case. It is a central tool for queuing auditd logs during investigation. All search to pull events by key, syscall UID. All report are summarized views. For instance, if you have seen my Linux threat detection 1 walkthrough, you have seen that I have used the all search command for that walkthrough as well. Sweet. All right. App specific logs. In SOC, you might also monitor a specific program, and to this effectively, you need to use its logs. For example, analyze database logs to see which queries were run, mail logs to investigate phishing, container logs to catch anomalies, and web server logs to know which pages were opened, when, and by whom. You will explore these logs in the upcoming modules, but to give an overview, here is an example from the typical nginx web server logs, which can be found at varlog nginx access.log. Also, we have bash history. Bash history is another valuable log source because it is a feature that records each command you run after pressing enter. And by default, commands are first stored in memory during your session, then written to the per user bash history file when you log out. You can open the bash history file to review commands from previous sessions, or use the history command, which I showed you before, to view commands from both your current and past sessions. Let me show you guys that. We can run the history command, and we can see the commands that we have run previously here. Awesome. And although the bash history file looks like a vital log source, it is rarely used by SOC teams in their daily routine. This is because it does not track non-interactive commands, like those initiated by your OS, cron jobs, or web servers, and has some other limitations. So while you can configure it to be more useful, there are still a few issues you should know about. First, attackers can simply add a leading space to the command to avoid being logged, which can be found here. Next, attackers can paste their commands in a script, which we can see here, to hide them from bash history. And third, attackers can use other shells like binsh that don't save the history like bash. Alright, we have some questions to answer below. According to the VM's packet manager logs, which version of unzip was installed on the system? So we're going to use our resource, Linux artifacts, package management. So we have dpk glog which is a chronological log of every package install, upgrade, and removal on Debian Ubuntu systems. And so we also have the different package management, logs as well for Yum, which is Rail and Fedora, and much more. So we're going to figure out what our distro is. So who am I? Ubuntu. All right, we're going to use, in this case, we're going to use at Pacific logs. So we're going to look at packet manager logs. So because Ubuntu is Debian, we're going to look at var log dpkg.log. All right, so let's do that. Cat var log dpkg.log. Nice. Oh, it's a big log. Awesome. And then we're going to look for, I believe we're going to look for unzip. There we go. All right. Grep unzip. And we have our logs here, and we see that there's a version 6.0-28 Ubuntu v.1. So let's see if that is our answer. Awesome. All right. What is the flag you see in one of the user's bash history? So let's go find that flag. So we're going to use bash history. So we need to do use cat home Ubuntu. And I believe it is dot bash history. And we see commands, but also we need to see the other users as well. So we're going to go to cd-home, click on ls. What else? I believe we can. There is also root. So we're going to go to root. Now we're in root. And so I can show you that I am root. Who am I? Root. Then we're going to do cat var. No, it's going to be cat root Ubuntu, and then dot bash history. I believe I spelled that wrong. Cat dot bash history. Okay. Cat root Ubuntu dot bash history. Oh, I see what I do. I see. Cat. Let's see if it's cat home. All right. For this question, I believe I need a space. So let's do cat room Ubuntu. Yes, oh, there you go. Cat room home Ubuntu. I needed a space dot bash history, and we can see all the commands here. And we're going to try to find that user. So we're going to do ls. So we're going to try to find the got what is the flag you see in one of the users bash history. So we're going to try to find I believe I can find this answer. Note to remember. All right, let's go back and click on ls. Let's go ls-l. Okay, so we don't. Let's go to cd home. Click on ls. Let's click on cd Ubuntu. Click on ls. pwd. All right. Let's do. It want to be a presentation. Cat home. Cat root Ubuntu. So what am I missing? All right, give me 1 second. Let's see what am I looking for. All right, so we're gonna go to, I had it right. So we're gonna go to sudo su, and then we are going to find, and by the way, there is no harm in Googling. So we're gonna go find that answer. Yes, so what we did was that we're going to do exit. Then we're going to do sudo grep -i thm because for flags in TryHackMe they have a format which is this root .bash history, and then boom, we got our flag. THM note to remember, which can be found here. Awesome. All right. Now, task 5, runtime monitoring. All right. Up to this point, you have explored various log sources, but none can reliably answer questions like which programs did Bob launch today, or who deleted my home folder and when. That's because by default, Linux doesn't log process creation, file changes, or network-related events, collectively known as runtime events. Interestingly, Windows faces the same limitation, which is why in the Windows login for SOC room, we have to use an additional tool, Sysmon. In Linux, we'll take a similar approach, and also a really helpful advice. The broader you log, the more threats that you can detect and analyze, which can be found here. All right, system calls. Before moving on, and let's explore a core OS concept that might help you understand many other topics. System calls. In short, whenever you need to open a file, create a process, access the camera, or request any other OS service, you make a specific system call. Now, there are over 300 system calls in Linux, like exec, VE, execute a program, and below is a high-level flowchart of how it works. So starting off, you start a program by typing who am I and pressing enter. Second, Your shell starts user bin who am I by saying the system call. Third, Linux kernel processes the details and starts the system call. And then 4, Linux kernel accesses hardware like CPU, memory, and disk. And then finally, the Linux kernel returns results and you see who am I as your output. Alright, why do you need to know about system calls? Well, all modern EDRs and logging tools rely on them. They monitor the main system calls and log the details in a human-readable format. And since there's nearly no way for attackers to bypass system calls, all you have to do is choose the system calls you'd like to log and monitor. And so in the next task, you would try it in practice using auditd, which can be found here. Alright, cool. I can see my yes. Sweet. Alright, we're still recording. Nice. Alright, to answer the questions, which Linux system call is commonly used to execute a program? And to find that answer, we can see here, there are over 300 system calls in Linux, like execve execute program. And if you wanted to see more about the system calls, you can click on this, and you'll see the system call. So if you wanted to see execve, search it, we can see here Linux manual pages, and what it does is that it executes program. Awesome. So that is our answer, execve. And now this, can a typical program open a file or create a process bypassing system calls? Nay. And because, why do you need to know about system calls? Well, all modern EDRs and logging tools rely on them. They monitor the main system calls and log the details in a human-readable format. And since there's nearly no way for attackers to bypass system calls, all you have to do is choose the system calls you like to log and monitor. So nay. Awesome. Alright, task 6. Using auditd. Alright, what is auditd? Let me explain. Auditd is the audit daemon. It is a built-in auditing solution often used by the SOC team for one-time monitoring. In this task, we will skip the configuration part and focus on how to read auditd rules and how to interpret the results. So let's start from the rules. Instructions located in etc auditd rules.d that define which system calls to monitor and which filters to apply. So we can see here an example of auditd, which can be located in etc configuration, audit rules.d, audit.rules. We have always log what follows here, monitor the system call, apply these monitoring filters, apply these tags for easier search, and just a comment, not part of the rules. So in terms of the format, we have filters as well. We have -a, -s, -f, and -f again. And that is an example of what auditd rules looks like as well. Alright. Monitoring every process, file, and network event can quickly produce gigabytes of logs each day. But more logs doesn't always mean better detection, since an attack buried in a terabyte of noise is still invisible. That's why SOC teams often focus on the highest risk events and build balanced rule sets, like this one or the example you saw above. So using auditd, you can view the generated logs in real time in var log audit.log, but it is easier to use the all search command as it formats the output for better readability and supports filtering options. So let's see an example based on the rules from the example above by searching events matching the proc regget key, which we can see here. And the terminal above shows a log of a single regget command. Here, auditd splits the event into 4 lines, such as the proc title shows the process command line, cwd reports the current working directory, and the remaining 2 lines show the system call details like PID, PPID, your process ID, and your parent process ID, AUID equals Ubuntu, your audit user, UID, which is the user who ran the command, TTY, which is your system identifier, EXE, which is your absolute path to the executed binary, and key equals procregit, which is an optional tag specified by engineers, and auditd rules that is useful to filter the events. So see file events. Now let's look at the file events matching the file shconf key. As you may see from the terminal below, auditd tracked the change to the etc shconfig file via the nano command. And SOC teams often set up rules to monitor changes in critical files and directories. For instance, SSH configuration rules, files, cron job definitions, or system settings. And we also have auditd alternatives. You might have noticed an inconvenient output of auditd. Although it provides a verbose logging, it's hard to read and ingest into SIEM. That's why many SOC teams resort to the alternative runtime logging solutions. For example, Sysmon for Linux, Falco, OSKiri, and EDRs. And the key to remember is that all listed tools here work on the same principle, monitoring system calls. So once you understood system calls, you'll easily learn all the mentioned tools here. So this knowledge also helps you to handle advanced scenarios like understanding why certain actions were logged in a specific way or not logged at all. Now, try to uncover a threat actor with process creation logs. And for this task, continue with the VM and use auditd logs to answer the questions. And you may need to use allsearch-r and grep commands for this task. So we have 3 questions to answer. So let's start with the first one. When was a secret.thm file opened for the first time? And note, access to this file is logged with the file thm secret key. And we have a hint. You can filter file access events with the allsearch-i-key file thm secret. So we're going to do that. And like I mentioned, to get more information about a command, you can command allsearch. And what allsearch is, it is a tool that can query the audit daemon logs based for events based on different search criteria. So we're going to do allsearch-i-k, and I believe it was allsearch-i-k file ssh conf. So we're going to do file H and we have our file events. And now what we are trying to find is the secret.thm file. Awesome. All right. Secret.thm, believe. Interesting. We have logs, we have audit rules, we have syscalls, we have add rules, audit rules, but I do not see secret.thm. So let's go back. All right. allsearch-k file thm here. Let's look at all the events. Oh, file thm secret key. I was using conf. So we need to do file thm secret. And there we go. All right. So file thm secret. Let's go find secret.thm. Key goes file thm secret. Here. Secret.thm. So I'm going to say we got our timestamp, which can be found here. So it's going to be 8/13/25, 1836/54. 1836. Okay, so I got 8/13/25, 1836/54. Awesome. All right. Next, What is the original file name downloaded from GitHub via wget? Note, wget process creation is logged with the proc regget key. And we also have a hint. You can filter wget execution events with all search-i-k proc regget. So we're going to try to find the original file name downloaded from GitHub via regget. So let's do that. All right. We're going to do all search-i-k proc regget. Proc regget. And we're going to try to find the original file name downloaded from GitHub via wget. So wget here. And we see GitHub. And we see that it is Nabu. So I'm going to say our answer is NAABU. And also we have a download as well. We're downloading a version of NAABU. Nice. Nabu, the version which we can see here. Booyah. Awesome. All right, last question. Which network range was scanned using the downloaded tool? Note, there's no data key for this event, but it's still an auditd logs. I have a hint. You might want to use grep in addition to auth search. Look for keywords like the tool name. So we're going to use grep to find. So we're going to do cat log. I believe we're going to do. Yeah, I got it. I got. So let's do cat var log audit.log, and let's search for grep network range, but it's still an auditd logs. You might want to use grep. Oh, grep. Okay. Grep. Boo. What did I do wrong? Auditd logs. Let me check to see if I got var log audit. Var log audit. Grep. There we go. We got our logs. Nabu. And we see a network range. Top ports. Awesome. Alright. So we see that. And what it wants us to find or answer with is the network range. So it's going to be 192.168.50.0 24 as our answer. Awesome. All right. Task 7, conclusion. Great job exploring the Linux log sources. In the upcoming rooms, you will put this knowledge into action to trace and investigate a variety of threats targeting Linux systems. Linux threat detection rooms, for example, from the initial access to the final attack steps. And you may need all log sources to fully uncover the breaches. And some key takeaways. Linux logging can be chaotic, but it often stores enough details to detect the threat. Logs are kept in var log folder by default and are usually stored in plain text. The top 3 log sources for SOC are auth.log, at-specific logs, and runtime logs. And bash history is unreliable for SOC. Better use case or better use auditd or an alternative solution. And to complete the room, you just need to click on correct, and you have completed all the tasks. And also the additional resources that we use for this room is Linux forensic reference, which can be found here with the different artifacts and tools, etc. Really helpful resource. I highly recommend bookmarking it. Explain shell. And also AI, but we made sure to verify the information is correct. Alright, so that being said, We're going to now close the room. Yes, I believe because I have it full screen, all I need to do is terminate the machine. Bye machine. And that's it. Alright. That's all the tasks for this room that we have completed. I hope you guys enjoyed my Linux login for SOC TryHackMe walkthrough. I will see you guys in the next walkthrough. Have a great day and keep up the great work. Peace.